Hello and welcome to Check Stoichiometry Live Office Hours. My name's Allison. I'm going to be hosting today. It's so glad to have all of you. If this is your first time joining, this is Check's office hours that they've provided to help you guys do great in all of your classes this semester. We have stoichiometry office hours every Wednesday and then regular office hours for different classes every day this week. You could check that QR code in the top left at any time to see the schedule of all the office hours offered for all kinds of different classes like math, chemistry, everything like that. I'm Allison. I've had TA experience in organic chemistry, regular chemistry, and then I've been a learning assistant and calculus tutor. I love stoichiometry. The goal of these sessions is for you guys to learn as much as you can, and we want it to be personalized to you. So I encourage you to type your own questions in the chat so that I can answer them for you. I've provided some questions for us to start with, but more than anything, I'd love to answer your guys' questions from your homework, from your class, things you're quite not understanding. Anything with stoichiometry and chemistry, I'd be happy to answer. So throughout our live stream, please feel free to type those into the chat. If this is your first time, welcome. Thank you for joining us. It is so great to have you, and let's get started. So to start tonight, we are going to warm up with balancing equations. This is a pretty simple task once you get the hang of it, but I know it's definitely a struggle and it only comes with lots of practice. So hopefully by doing two, we warm up for the rest of our problems, but we also learn and get that practice so that we can become super fast at doing these chemical equations and balancing them. I encourage you throughout the live stream to type the answers that you think are in the chat so that we can check our answers and compare at the end. But to start out, we're going to want to balance C2H6 plus O2 yields CO2 plus H2O. I'm going to give you guys about 15 seconds to try to start working on that on your own, and then we're going to jump in together and I'm going to show you how I would solve this problem. So I've got about 15 seconds. All right, we're going to go in 5, 4, 3, 2, 1. Okay, so my first strategy with these is to balance everything but the O's. The reason that we wait to balance the O's last is because the O's we can kind of change since they're alone on the left side of the equation, but we know that the C's and the H's are always connected to something. So I like to start with my carbons. I see that I have 2 carbons over here, so I'm going to put 2 carbons on the right. Then that means I have 6 H's on the left, so I'm going to put 6 H's on the right. I put that 3 before because 3 times 2 equals 6 H's. Then I'm going to balance my O's. So I have 4 O's in this from 2 times 2, and then I have 3 O's over here. So in total, I have 7 O's. And I can't really make a whole number. So I put 3.5 as a place, like as a little placekeeper. But if I wanted to truly balance this, since I know that I need 3.5 O2s to balance my 7 O2s on the right, I would just multiply all those coefficients in the equation by 2. So that imaginary 1 in front of the C2H6, we'll use a different color so you can kind of see what I'm talking about, would become 2 C2H6. That 3.5 O2 would become 7 O2. The 2 CO2 would become 4 CO2, and the 3 H2O would become 6 H2O. So now let's count and check our carbons, hydrogens, and oxygen balances one last time. So we have 4 C's over here, and then we have 4 carbons over here. So we're good on our carbons. Then I go to my H's. I have 12 H's on the left, and then I have 6 times 2, so 12 H's on the right. I'm good with my H's. And then last but not least, I'm going to check my oxygens. And I have, 8 oxygens plus 6 oxygens is 14 oxygens on the right. And then I have 14 oxygens on the left. So that means that my equation is balanced. Those final coefficients are 2, 7, 4, and 6. If you have any questions about how I got that, how do I solve, if you want more practice, type that in the chat and let me know. If you're just now joining, thank you so much for joining our Chegg Stoichiometry Office Hours tonight. Chegg is really here to help you guys learn all the content that you're struggling on. And I encourage you throughout the night, any questions that you have, type those questions in the chat so that I can answer them for you. That is what I'm here for, and I'd be more than happy to help you in whatever you need. So now we are going to move on to our second balancing equations problem. So this one, I wanted to challenge you guys a little bit. I wanted to see if you guys could come up with the products to this chemical equation. I'm going to give you guys about 30 to 45 seconds to try to figure out if you can come up with those products and how would you balance it. So I've got about 30 seconds. All right, we'll go about 10 seconds longer. And type those answers, what you think, in the chat so that we can check them and make sure that they are right, and then figure out where we're struggling. All right. So 3, 2, 1. All right. So this is a double replacement reaction is what this is called. So basically, we're going to replace the beginning, which is the cation, with the second anion, which is going to make us KCl. And then we're going to replace the second cation with the first anion. Whoa, words. And we're going to get AgNO3. So does anyone have any questions on how I got that KCl-AgNO3? Ethan on TikTok asked, where do I get the K from? That K is from this KNO3 in my first reactant. That's potassium. So since this is a double replacement reaction, the potassium in the KNO3 is going to go with the chlorine in the silver chloride. Yes, that is potassium, correct. So that's where I get the K from. Since it's in my reactants, it has to be in my products. I can't forget anything in between. And I saw a question about going over oxidation and reduction. If you have a specific example, I would love to go over that. Type that question in the chat, and I'd be happy to go over an oxidation and reduction example with you. So now that we have this equation figured out, like what our reactants are, what our products are, let's figure out what those coefficients are. So I'm going to balance everything I have. I have 1K over here and 1K over here. So I don't really have to do anything there. And then I have 1NO3 over here, and I have 1NO3 over here. Don't have to do anything there. Then my AGs match up and my CLs match up. So this was kind of a trick question. We don't need to do any balancing here. It's already balanced for us. It was just more so you guys could see how we come up with the reactants and products. And sorry, I should have been more clear. These are two separate problems. So this top was the first problem, and then the bottom was the second. So we are on to a whole new problem. If that double replacement reaction isn't making sense, type that in the chat. I can go through it more thoroughly. We can do more examples. I would love to help you. There's also single replacement combustion. If you need any help on those reactions, type those up, and I will answer all of those questions. But now we are going to move on to our third question. Our last warm-up question is, how many moles is 72.04 grams of C3H8? If you're just now joining, welcome to the Chegg Stoichiometry Live Office Hours. I'm Allison. I'm so happy to have you. I encourage you throughout this live stream to ask any questions that you have. Type those questions in the chat. I would love to answer them. And thank you so much for joining. All right, so we have, how many moles is 72.04 grams of C3H8? So there's something we need to figure out first before we can solve this problem. Does anybody know what that is? I'm going to give y'all about 10 seconds to figure out how we know, like, what that step is that we need to get from grams to moles. All right, 5, 4, 3, 2, 1. We need molar mass. To find that molar mass, we have C3H8. we count our carbons. So we have 3 carbons, and we do 3 times the molar mass on the periodic table. Mar from TikTok, great job. Molar mass is the answer. So we go to our periodic table and find the molar mass for our individual carbon atom, and that's going to be 12.01. And then we go to hydrogen. We go to the periodic table, and we have 8 of those that we can tell from that little subscript. And if we look at the periodic table, we have 1.01 grams per mole for that. Now we need to solve these multiplication problems. I'm going to give y'all about 25-30 seconds. Put that in your calculator and let me know what you get when you multiply those across. Type that answer in the chat when you are ready. All right, about 5 more seconds, guys. Remember, type those answers in the chat so we can lock in our answers and check them. 3, 2, 1. If you said 36.03 for the first one, you are correct. And if you said 8.08 for the second one, you are correct. Now we're going to add those together to get our final molar mass of that C3H8. So add those together in your calculator. Let me know what you get. All right, 3, 2, 1. If you got 44.11 grams per mole, you are absolutely correct. So now let's answer that question that we started with. How many moles is 72.04 grams of C3H8? So we're going to start with what we're given, and we are given 72.04 grams. Now, I'm going to pause for about 30 seconds because we've been going over this for the past few weeks. So I want to see if you guys can get the math together and solve it. I want y'all to type those answers in the chat so we can check in, make sure we're understanding. But how am I going to get from this 72.04 grams of C3H8 to moles of C3H8? We already have some of the pieces here. So y'all have got about 20 seconds. Let's see what all we've learned. All right, about 10 more seconds, guys. All right. If you said that we're going to use our molar mass, you are absolutely correct. So we are going to put grams on the bottom because we want to cancel out grams on the top with grams on the bottom because we want moles in our final answer, moles on the top. The number always goes with the grams. So we're going to do 44.11 on the bottom, 1 mole on the top. If you said atomic mass, great job, Taylor from TikTok. And now let's put that answer in the chat. If you are just now joining for your first time, I always set up my stoichiometry problems like this. And the reason is because when I get to this step, I multiply the top and I divide the bottom. So it's really easy for me to put into my calculator. And all I have to put in is 72.04 over 44.11. That's what I mean by multiply the top, divide the bottom. So let's put that in our calculators. And if you got 1.63, you are correct. Great job, Mar from TikTok. You absolutely divide them. So we have 1.63 moles of C3H8. So hopefully that was a great warm up for you. I'm now going to answer a little conceptual question that we had. From Mar on TikTok, we had, how do you know if an element is getting oxidized or reduced? This is a great question. It tricked a lot of my students up when I was a TA for chemistry, but I like this simple little acronym that's LEO says GER. And this is going to help us see what gets oxidized, what gets reduced. So we say loses electrons, oxidation, meaning if that molecule, atom, whatever it is, loses electrons, it was oxidized. And then we say gain electrons means reduction. So if a atom, molecule, whatever it was, gains electrons, it is reduce. That is the way I remember oxidation and reduction. And this has stuck with me since like ninth grade chemistry. So I think it's a pretty good acronym. Acronyms are always a great way to learn and remember the content that you need to know. So this is a great way to learn it. If you have a specific example of the oxidation and reduction reactions, I would love to help and answer that for you. But this is how I remember what gets oxidized and what gets reduced is this acronym. If the molecule loses electrons, it's oxidized. If it gains electrons, it's reduced. And that is always true. It's a great tool to learn about oxidation reduction. So ask me more questions about that if you have them. So now I want to move on to a new topic that we haven't really discussed before, but we had some questions on it last week. This is limiting and excess reagents. So limiting and excess reagents basically tells us what's going to limit our chemical reaction from making the most product. And every chemical reaction, the ones we'll focus on will have two reactants. One reactant is going to limit how much product we can make. And another reactant, our excess reagent, is going to be able to provide for those products in excess. So one, the limiting reagent is going to limit how much product we make. One is not, and that's the excess. So we have what is the limiting reactant in the following equation if we start out with 30 grams of each reactant. So for this problem, we have to start by balancing our equation. After I answer this question more on TikTok, I will get to that oxidation reduction reaction and we'll talk about it. But we're going to fix and solve this one first. So we need to balance this equation. So we start with our carbons. If we have 4 carbons on the left, 4 on the right. Now, I encourage you, try to beat me in balancing this equation. I'm going to go slow, so see if you can beat me. Let's see how much practice you've had with balancing those equations. All right, so then we're moving to our H's. We have 10 H's on the left, and then we have 2 on the right, but I can put that 5 as a coefficient and balance that and make it 10 hydrogens. And last but not least, we're going to do our oxygens. We have 8 plus 5 oxygens on the right, 13. So we would put 6.5 on the left, but then again, we can't have halves in our balanced chemical equation. So we're just going to multiply everything by 2, and I'll use a different color just so you can see that multiplication. We have 2, 13, 8, and 10. And then let's do a final check. We have 8 carbons and 8 carbons, 20 hydrogens, 20 hydrogens, and then 26 oxygens and 16 plus 10 oxygens, 26 oxygens. So my equation is fully balanced. Did everybody get that? Everybody understanding how to balance the equations? Let me know in the chat. Now we are going to find the limiting reactant. So the way we do that is we start with what the equation gives us. And the gives us that there's 30 grams of each reactant. So I'm going to start with 30 grams of C4H10 and of O2. Now, with this, I'm then product that I want to put both of my reactants to moles. I'm going to choose my CO2 just because there's less of a coefficient in front of that CO2. It's 8 as opposed to 10. So I feel like it'll give us a lower number. So I'm going to choose CO2 to go to. And this is on. So now reactants to moles of each of my reactants. Now, reagent problems is to find the limiting reagent, but the way we find that is by finding which of these reactants is going to give us the fewest moles of product. So that's why we choose one product to take both of the grams of reactants to find which of that reactant is going to make the least amount of product. So with that, I need the molar mass of each of these. We've worked on molar mass a little bit. I'm going to give y'all a minute to figure out the molar mass of each of those. And I want you all to type your answers in the chat when you're done. I am going to solve them, and then I'll do a quick little writing on the board so we can see, but I am going to speed through it. I want you guys to try to find the grams per mole and molar mass alone this time. So y'all have about a minute to do that. And again, type those answers in the chat once you have found them. All right, we've got about 30 more seconds. Let me know what you guys get. All right, about 10 more seconds, guys. Type those answers in the chat. And again, if you have any questions that you are wanting to know the answer to, type those in the chat. I'd love to answer them for you. We already have one queued up for next. So type those in if you want your questions answered, guys. I'd love to answer them for you. All right, let's find those molar masses. So for the C4H10, I would do 4 times my 12.01 for carbon, and I get 48.04. Then I'd do 10 times my 1.01 for hydrogen, and I'd get 10.1. Then I add them together, and I get 58.14. That's my molar mass for C4H10. For O2, I would get 2 times 16, which is 32. All right. Did everyone understand how we got those molar masses? Type in the chat if you got them. I'm so proud of you guys. And let's put those molar masses in. So we had 1 mole was 58.14 grams of C4H10. And we had 1 mole here was 32 grams of O2. And then we're going to do that molar ratio. We've briefly touched on this in some past weeks. I've tried to sprinkle it in. But basically we do molar ratios. And the molar ratio is just the coefficients in the balanced chemical equation. So I'm going to circle all of them in green. These are our coefficients, that 2, 13, 8, 10. We're going to plug those in once we write out these mole formulas to figure out how many moles of product we're going to make. So we would label it moles of C4H10, and we're trying to get from moles of C4H10 to moles of CO2. Same at the bottom, moles of O2 to moles of CO2. And again, we're going to the same one so that we can compare both reactants to find which is going to make less product. And then I'm just going to look at my chemical equation, find the coefficient in the balanced chemical equation associated to that molecule, and I'm going to write that in the space. So for C4H10, I find 2. So I write 2 for moles of C4H10. For CO2, there's 8. And I found that 8 right there. Same right here, 8 moles of CO2. And then for moles of O2, I have 13. So I'm going to write 13 there. Then I am going to solve it. Sorry, guys. I'm going to solve across and figure out how many moles of reactant I made. If you want to get from moles of one thing to moles of another, the only way you can do that is through molar balancing of the chemical equation. So I'm going to give you guys about 1 minute. Put that in your calculator. Let me know what you all get. Type in the chat what you guys get so you can lock in your answer and we can check it together. All right, keep working. I'm putting the answer for the top one in at the top, but don't look until you solved it. All right, about 30 more seconds, guys. Five, four, 3, 2, 1. If you got these answers, you are absolutely correct. Now, tell me, which one is the limiting reactant, guys? Remember, the limiting, it's what limits us to make more product than we can. So whatever makes the least amount of product is going to be our limiting reactant. So in this case, it would be 0.577 moles of CO2, which is oxygen. So we would write out, if we had this problem on a test, O2 is our limiting reactant, and that would be our answer. If you guys are understanding, give me a thumbs up. If you want more practice, let me know in the comments. We are now going to move on to a question from Mar on TikTok. Identify what is being reduced and oxidized in the chemical equation. I'm going to write it out so we can all see. 2I plus Cl2 yields 2Cl plus I2. So, and this I has a minus, and I'm going to assume, yep, this Cl has minuses signs as well. So, we are now going to figure out what is being reduced, what is being oxidized. To start out, we need to find the electrons in each of our elements. So our elements present are iodine and chlorine. When we have something like Cl2 or something without a plus and minus sign in the top right corner, that electron number is always going to be 0. So our chlorines at the beginning are zeros. Our I's at the end are zeros. We have a minus on this I and a minus on this chlorine. Now, a negative sign indicates 1 electron. So this equals 1 E minus. E minus is electron, if you're wondering what I am writing. A 2 minus equals 2 electrons, and a 3 minus would equal 3 electrons. So the way this problem is written is indicating to us that there is 1 electron present in this iodine. So we have 1 electron, and that's going to 0 electrons, because in our final answer, there is no charge, it's 0. So if we go from 1 electron to 0 electrons, we are losing electrons. And if that's for iodine, so if we're losing electrons, we have Leo says, Gur, iodine is being oxidized. Now, going off that same principle, we have Cl2 that starts at 0 E minus and goes to 1 E minus. So we are gaining electrons. We're going from no electrons to 1 electron. So our chlorine is being reduced. And just remember that little acronym I said earlier, Leo says Gur. And that will tell you in this problem what's getting oxidized, what's getting reduced. Hopefully that answered your question. If you have any more follow-ups, if we're wanting to look at oxidation reduction more, we can do some next week. Or if you guys have those examples, I'd love for you to type them in the chat and we can work out more. But hopefully that helped kind of explain how oxidation and reduction reactions work. And then we got a comment from TikTok for this last problem we did that I got the answer in grams and still got oxygen as a limiting reagent. You can take these moles to grams and you'll still get the same answer if you take the moles of the product to the grams of the product. It's kind of a personal preference. I just prefer this way because it's less steps, so it makes it easier for me and saves time. I think it's more efficient for a test, but you're definitely not wrong in going to grams, so it's great that you can make that connection. But yeah, even if you move it 2 grams of the carbon dioxide, you're still going to get oxygen as the limiting reagent, so great observation. All right. If you're just now joining us, welcome to Chegg Stoichiometry Live Office Hours. I'm Allison. I'm hosting today. I'm so glad that you're here. We have office hours all week long that I encourage you to join. These office hours are for chemistry. They're for math. We have all kinds of different subjects. I encourage you check that list in the top left to figure out what courses match up with your schedule. Also, the point of these help sessions is for you to get your answer to your problems that you need. So type those homework problems in, type those things in that you're struggling with in class in the chat, and I would love to answer them for you. All right. Now, going on to the next problem. If we start with 70 grams of limiting reactant in the problem above, how much carbon dioxide would we end with? So this problem I think is a little easier maybe than I intended, but it's okay. We're going to do it and we're going to get that practice in so that we do great on our upcoming tests. So we're starting with 70 grams of our limiting reactant. We determined our limiting reactant to be oxygen. And also, if you can work faster than me, I encourage you, beat me in solving this problem. Type that answer in the chat so that you can lock in your answer and try to test your knowledge and see how much you're understanding these concepts. So I'm going to start out with 70 grams. Let me change colors so that we can kind of tell the difference between the problem. I'm going to start out with 70 grams of O2. And then I found that molar mass up above. It was 32 is what we determined. So I'm going to go from grams of O2 to moles of O2. So 1 mole is 32 grams. And then we want to know how much CO2 would we end with. I didn't really specify if we wanted moles or grams, but since we've had people pointing out we can go to grams, let's just go to grams. Let's find out how many grams of CO2 would we make up. So then we're going to go from moles of O2 to moles of CO2. So if you know how we do that, I'm going to give y'all about 15 seconds. Type that in the chat. Let's see how good y'all are listening. How do we get from moles of oxygen to moles of carbon dioxide? All right, 5, 4, 3, 2, 1. Okay, we use those coefficients of the balanced equation. So for moles of oxygen, I have 13. And for moles of CO2, I have 8. Is everyone understanding where I'm getting those coefficients from? If you're not, type in the chat so that I can go over it more closely. I know the people that I TA really sometimes struggle with grasping the concept of where do I get these coefficients. So I would love to go over that in more detail if you have any questions. And then last but not least, we're going to go from moles of CO2 to grams of CO2. I'm going to give y'all about 30 seconds to find that molar mass of CO2. And if you take lots of chemistry classes like me, I'm a chemical engineering major, you will end up knowing this molar mass of CO2 off the top of your head. So practice makes perfect. Let me know, how do I get the molar mass of CO2 and what is its molar mass? All right, we've got about 15 more seconds. What is that molar mass? Let me know in the comments, guys. All right, 3, 2, 1. It is 44.01 grams per mole. Great job if you said that, guys. Now, I'm going to give y'all a minute to put that in your calculator. All right. Y'all have got about 30 more seconds. About 15 seconds. Let me know what the answer is. Can you beat me to it? Five, 4, 3, 2, 1. If you said 59.24 grams of CO2, you are absolutely correct. Great job, guys. Okay, From Mar on TikTok, we have create a KEQ equation from a balanced equation. So I'm going to do my best to touch on this concept. I'll try to get some better examples in for our live stream next week. Normally, these are more word problem associated. So I am going to just kind of show you this concept with, let's do this first, this second thing we balanced down here. So we're going to focus on this problem. We are going to assume that all of these are aqueous. Now, when we're doing these KEQ equations, you can only put aqueous things in the KEQ equation. So the way that we're going to do this is a KEQ equation. Oh, if I can ever say that. A KEQ equation is like our rate of reaction. It determines how fast are we going to get from reactants to products. So what we say is that reactants over products equals some rate constant. And the rate constant is always K, hence the KEQ equation. So for this, we would put the concentration of our aqueous reactants, so KNO3 and AgCl, over the concentration, these brackets mean concentration, of our aqueous products. So KCl and AgNO3. So that would be our basic rate equation for this problem. So our basic KEQ equation. Now, let's say our AgNO3 was a solid. If that was a solid, we would take that out of our KEQ equation. Solids, liquids, gases are not in those KEQ equations because they are not considered to affect the rate of reaction. If we had, let's say, we had 2 KNO3 for some reason plus AgCl yields KCl plus AgNO3, we would put a 2 exponent on that KNO3, and that would happen for any aqueous. If we change that coefficient before, the exponent would change to whatever number we changed it to. So this is kind of just how a KEQ equation works. I'll try to find some better examples. If you have any, type them in the chat, and I love to answer them for you, but this is just basically what a KEQ equation is. It's always reactants over products equals some rate constant, which in chemistry we always label it K. And then we got how much CaNO3, so that's calcium nitrate, should be weighed out to have 0.650 moles. And that's from Mar on TikTok. So I think that's a great question. Let's solve that. How much calcium nitrate should be weighed out to have 0.650 moles? So we have 0.650 moles of CaNO3, and this is calcium nitrate, and we want to get it to grams. So what we're going to need is that lovely molar mass. So we need to find the molar mass of calcium nitrate. I'm going to give you guys about a minute to find that molar mass, and then we're going to work through it together. I might write some things up on the top kind of to give you guys hints, because this is a little bit tricky to find the molar mass of, but see if you can beat me in solving for the molar mass. And type that answer in the chat when you get it so that you can lock your answer in and check and see how you're doing. All right, about 30 more seconds. See if you can beat me in solving this molar mass. All right, about 15 seconds, guys. You got this. Let me know what that molar mass is. All right. 4, 3, 2, 1. Okay, so just to catch you guys up on what I did, I first wrote down how much of each atom I had in my overall molecule. I have 1 calcium. Now, where it gets tricky is I have 2 nitrogens because if we have anything in these parentheses here, we basically multiply the subscripts of everything in the parentheses by that subscript of the parentheses as a whole. So I would multiply 2 times my 1 to get 2 N's. And then same with oxygen. Since I have 3 in the parentheses times 2 on the outside, I get 3 times 2 equals 6 N's. I then went to the periodic table. I found the molar mass of each of my individual elements. So I'm underlining it just to kind of show you guys what I found on the periodic table, and you can easily find it. It's the number that's not normally nice and pretty and whole. It's going to have some decimal points, and that is what the molar mass is. Then I just multiplied across, and I got those answers to my multiplication problems, and now I'm going to add them all up. So into my calculator, I'm going to put 40.078 plus 28.02 plus 96. And you should get 164.098 grams if we're working with sig figs, which we've touched on earlier. Basically, it means whatever we start with in terms of non-zero significant figure numbers is what we end with. So since we have 3 sig figs there, so 1, 2, 3, we end with 3 sig figs. So we would say 164 grams of CaNO32 should be weighed out to have 0.650 moles. And hopefully that helps answer your question. If you're just now joining, welcome to Check Stoichiometry Live Office Hours. If you need more homework help, you can scan the QR code in the top left. We are so glad and happy that you are here. Throughout this live stream, I encourage you to leave questions that you have about chemistry, about stoichiometry. I'd be more than happy to answer them. I would love to answer all of your questions. That's what I'm here for. And I'm so glad that you guys are here. All right, now we are going to move on to another limiting reagent problem. Hopefully that answered your question, Mar from TikTok. If you have any more questions about anything, just type that in the chat. I'd be more than happy to answer it for you. So now we are going to do what is the limiting reagent if we start with 40 milligrams of each reactant below. So let's balance this equation. So we have 1C on the left, 1C on the right. 2 S's on the left, 1 S on the right. So I'm going to make that 2. And then we have 2 times 2 is 4 O's plus 2 O's. So we need 6 O's on the left, 6 O's on the right. We have 3 times 2 for the left to get that 6. So let's do one final check just to make sure our left atoms match up with our right atoms. And we have 1 carbon, 1 carbon. 2 sulfurs, 2 sulfurs. 2 plus 4 oxygens is 6. 3 times 2 oxygens is 6, and our oxygens are balanced. So we are perfect. All right, now let's find that limiting reagent. All right, for this one, we're going to do the same thing we kind of did earlier. I'm going to give you guys about 3 minutes to solve these because they are longer problems. Then I'm going to start writing about a minute in so that you can kind of see my progress. And at the end of 3 minutes, we are going to review my work so we can kind of see how we got from point A to point B. And then if you guys have any other lasting questions, let me know, and I'd be happy to answer them for you. But my goal today is to really get us to master the topic of limiting reagents. All right, so I'm going to get y'all to have a minute head start, and then I'm going to start, and we are going to see how much we've learned. And type the steps in the chat and the answers you get. So like molar mass, whatever you need to find so we can lock in those answers and check together. I think it really helps learning and make sure you're being held accountable for learning, make sure I'm being held accountable to make sure everyone's knowing what's going on. So I encourage you to put those answers in the chat. All right, so I'm going to start working. I encourage you to work through this on your own, but if you get stuck, look up at the board and I will be writing, and so hopefully it'll help you in whatever you get stuck at. All right, again, if you get stuck, look up on the board and you can kind of check your answer to see how you're doing, or maybe it'll help you with wherever you're stuck at. All right, now let's all reconvene. Let's kind of see the thought process behind solving one of these, and we'll do that last step together. So, my first thing I did was find the molar masses. You can see where I found them in green. I basically looked at my reactants and then I went to the periodic table, matched up atoms times molar mass of the atoms, added that together to find my molar mass for each molecule. So for the CS2, I had 1 carbon times 12.01 grams per mole equals 12.01. I had 2 sulfurs times 32.07 grams per mole equals 64.14 grams per mole. And then I added those two together to get overall 76.15 grams per mole of CS2, which is carbon disulfide if you're working on naming at all in your chemistry classes. Then I went to oxygen. I had 2 O's, went to the periodic table, found 16 grams per mole, and got 32 grams per mole in total. And then I went to my stoichiometry, time for stoichiometry, the whole point of this. And I started with what I was given. I was given 40 milligrams, and you can find these next steps in blue. I was given 40 milligrams of each reactant to start with. I then went from milligrams to grams. That's that conversion that I told you we kind of have to memorize milligrams to grams, grams to kilograms, all of that. So I knew 1 gram had 1,000 milligrams in it, so I was able to write that conversion factor for each of my milligrams of oxygen and CS2. So I had 40 milligrams of CS2 to grams. Then I went from grams to moles because I need that molar ratio to get to the moles of the product that I chose. So I found that molar mass earlier, just went through that, and I put that in my grams, and now I'm at moles of CS2, and then I look at my balanced chemical equation for that molar ratio I need for the last step, and it's 1 to 1. Both my CS2 and carbon dioxide have 1 as the coefficient. And so now we're going to put that in the calculator. So if I were to put that in my calculator, I would do 40 divided by 1,000 divided by 76.15, and I would get a really small number. So it should be 5.25 times 10 to the negative fourth moles of CO2. Then for the bottom, I started with my 40 milligrams of oxygen. And again, if you have any questions throughout this explanation, type those in the chat. I'd be more than happy to answer them for you. I started with my 40 milligrams of oxygen, went from milligrams to grams. Again, that 1 gram equals 1,000 milligrams conversion. Then I used my molar mass, found that up above. I know that there's 32 grams per mole in O2, got to moles of oxygen. Then I put moles of oxygen at the bottom. That should be CO2 at the top. My bad, guys. I wrote that wrong. Moles of oxygen to moles of carbon dioxide. And that coefficient in my balanced chemical equation in front of oxygen is 3. So I put 3 at the bottom, and then I'm going to put that in my calculator. So what I put in my calculator is 40 divided by 1,000 divided by 32 divided by 3. And I get 4.16 times 10 to the negative 4 moles of CO2. So in this problem, oxygen is my limiting reactant because it made less of my product. Is that concept making sense to everyone? How we get the limiting reagent? It's whatever makes less product. I'm going to write it out just so if you're taking notes right now, I really encourage you to write this down. Limiting reagent or reactant, whatever you or your teacher calls it, makes less product. So in this case, O2 is the limiting reagent. This is what we would write if we were taking a test together right now. That would be nice if we could all take tests together. All right. So hopefully, as far as finding limiting reagents, that makes sense to you guys. I really hope it does. But again, let me know in the chat, in the comments, if you're on Twitch, TikTok, YouTube, whatever you're on, let me know if that's making sense to you, how you're doing with this limiting reagent concept. Now, since we've been working on limiting reagents all night, I wanted to do a little challenge problem. And I'm trying to trick you. Don't let me trick you guys. So if you can solve this question before me, I'll be very, very impressed. You'll get a virtual high five. But it's if we start with 60 milligrams of excess reagent, how much SO2 can we make? So I'm going to give y'all about 30 seconds. Tell me, how would we go about solving this problem? What steps will we need to take? What will we need to do to get that? How much sulfur dioxide could we make? And again, we are coming to the end of our live stream. So if you have any last minute questions, any last final questions, type those in the chat so that I can answer them for you. I want you guys to get the most out of this live stream. If you're just now joining in, thank you so much for joining us. I encourage you to join other help sessions and other live streams of the office hours throughout the week. There's a QR code above with all of that information. But ask those final questions right now if you have them while we are solving this last problem. All right. So what we need to do is, since limiting reagents determine how much product we can make, we need to get this 60 milligrams of excess reagent, which is if O2's our limiting reagent, CS2 is our excess, so we have 60 milligrams of CS2. We need to get that to grams or moles of our oxygen, which is our limiting reagent. So I'll do milligrams of CS2 to grams of CS2 because I can only go from grams to mole. Grams of CS2 to moles of CS2. And then actually, if we were to go to grams in this instance of the oxygen, we'd be adding an extra step. So we're going to stop at moles of O2. And you'll see why. If you don't already know, you'll see why in just a minute. Oh, wrote that wrong. Moles of CS2 to moles of O2. So I have all my steps wrote out. I'm going to now fill in the blanks. 1 gram is 1,000 milligrams. 1 mole of CS2, going back to that molar mass, is 76.15 grams. And then 1 mole of CS2 is 1 mole of O2. Goodness, I can't talk tonight, guys. All right, and then we're going to put that in the chat. So that's our first step to this problem. No, we're not going to put it in the chat. We're going to put it in the calculator. So we do 60 divided by 1,000 divided by 76.15, and we should get 7.88 times 10 to the negative fourth moles of O2. If you got that answer, put a thumbs up in the chat. Let me know. And then we're going to need to get from this moles of O2 to our SO2. So any ideas on how we would do that? All right, what we're going to do is we're going to put 7.88 times 10 to the negative fourth moles of O2. And we're going to go from moles of O2 to moles of SO2, because that's what the problem asks, and then moles of SO2 to grams of SO2. What do we need before we can solve that? Does anybody know? We need that molar mass of SO2. So we have 1S, which is 1 times 32.07. So 32.07. And then we have 2 O's. So 2 O's is 2 times 16. So 32. So our overall molar mass is 64.07. So we have 64.07 grams per 1 mole. And then going back up to that balanced chemical equation, we have 2 moles of SO2 to 1 mole of O2. Let's put that in the calculator. So 7.88 times 10 to the negative fourth times 2 times 64.07. And we should get about exactly 0.1 gram SO2. If you got that answer, type it in the chat. Let me know. So proud of all of you guys today. We are doing so well. All right. And that is that question. Okay, we have about 2 or 3 minutes left. So this is your final chance to ask a question. If nobody has any, we're going to speed run this problem. We're going to say, since we don't have that much time, we're going to take away this exponent because I think we're doing good with scientific notation. I got a question from Avoid321 on TikTok. Can you do an ice table problem with scientific notation? I will get one ready for next week. Those take about 10 minutes to do sometimes, so I'll definitely have one next week. Come back next week and I will do one for us then. But we don't have time right now. I can answer some conceptual questions, though, if you have one. But definitely next week, come back and we will talk ice tables, reaction rates, all of that fun stuff. So we have 6.04 millimeters per hour. We want to get to kilometers per second. The first thing I would do is go millimeters to meters. I focus on one. I'm focusing on the top first. And then I would go meters to kilometers. Then I'd focus on the bottom. I need hours. It's millimeters. I need to seconds. Okay. I'd go hours to minutes. And then I'd go from minutes to seconds. So we have 1 meter is 1,000 millimeters. 1 kilometer is 1,000 meters. 1 hour is 60 minutes, and 1 minute is 60 seconds. So let's put that in the calculator. I think by taking the scientific notation part out, this is going to be a really, really small answer, but it's okay. We'll get practice writing the scientific notation. So we do 6.04 divided by 1,000, divided by 1,000, divided by 60, divided by 60. And with all those zeros in your calculator, you will get 1.678 times 10 to the negative 9 kilometers per second. And we know that because we can cross out millimeters, millimeters, meters, meters, minutes, minutes, hours, hours, and we're left with kilometers over seconds. Okay, I see some great questions coming in. We are about at time for tonight, but I think this is a great moment to plug in all of the other office hours we have. I will be back next week, and I promise I'm taking note of the questions you have. Mole ratios, ice tables, KEQ equations, reaction rates, oxidation reductions, All those questions you asked, I will put in our review for next week. I also encourage you to come with prepared questions about those topics that I love to answer for you guys. But we will definitely focus on those next week. So please come back to our stoichiometry office hours, same time. You can join from Twitch, I think, YouTube, TikTok, all of those. So I encourage you to come back. Now, also in the top left here, if you're taking other college classes this semester or other classes in high school and you are needing some help in those too, top left is the QR code for our other office hours and homework help. I encourage you, check what we have to offer. We have chemistry, calculus, math, anything you can think of. Chegg is so great in providing for college students. They're helping everyone to learn the most this semester and just get the most out of what they are learning. I encourage you to check that QR code out. Thank you so much for coming today. I'm so great and so lucky to have you all. And I look forward to seeing you guys next week where we'll go over all your questions. Thank you guys.